Welcome back, everybody. The last time we got together, we went through this first complete example of a repeated measures analysis of variance. And by the time we got to the last step, we were able to complete this entire ANOVA source table. Let's imagine for a minute that we didn't have that entire table filled out, and we had a little puzzle that looked like this. By working through these puzzles, it helps us better understand how different parts of the table interact with various other parts of the table. Let's switch views and work on this together. Right here I have the incomplete source table, and on the slide right above it, I have formulas to help us figure out how to fill in the values that are missing. Let's go back to the source table and remind ourselves of what we were dealing with. Here's the important information that we need. It says, recall that the data represents wellness scores for 5 people across 4 treatments. There were 5 people who suffered from depression, and we tested them across 4 different treatments where each treatment had a different level of drug, 0 milligrams, 10 milligrams, 20 milligrams, or 30 milligrams. Based on that information and the numbers that are in the table already, we should be able to fill in all of the missing data. You might recall that when we've worked on puzzles like this in the past, it's always easiest to start with the column for degrees of freedom. That's primarily because the formulas for computing degrees of freedom are really very straightforward. Let's take a look. For example, one cell that had missing information was this one right here, degrees of freedom between treatments. That value is based on the number of treatment groups minus 1. In this particular research study, there were 4 treatment groups. 4 minus 1 equals 3 degrees of freedom. And we might as well take a minute to see if that fits. 50 divided by 3 should equal 16.67. Let's check that. 50 divided by 3 equals 16.67. So we're on the right track. Let's stick with that degrees of freedom column. Let's remind ourselves of the formulas. One value that was missing from the table was degrees of freedom total. Degrees of freedom total can be computed by taking the large N and subtracting 1. Remember, that large N, that capital N, represents the total number of measurements we have across all the participants and all the treatment groups. In this study, we had 5 people and we measured each one of them 4 different times. In other words, we had 20 measurements. 20 measurements minus 1 equals 19 total degrees of freedom. That number makes sense because remember, another way that we can compute degrees of freedom total is by taking degrees of freedom between treatments and then adding to that degrees of freedom within treatments. 3 plus 16 does indeed equal 19, so we're on the right track. Do you remember how to compute degrees of freedom error? Degrees of freedom error is simply degrees of freedom within treatments minus degrees of freedom between subjects. 16 minus 4 equals 12. Let's check that value because there's another formula that we can use to compute it. Let's remind ourselves by looking at the formulas. Here's that other formula that I was just talking about for degrees of freedom error. We can take the number of treatment groups minus 1 and multiply that by the number of people that were measured minus 1. There were 4 treatment groups. 4 minus 1 is 3. And there were 5 people who were measured. 5 minus 1 is 4. 4 times 3 is indeed 12. So no matter what formula we use to compute it, we're getting the same answer, so that means we're on the right track. Let's focus on this cell next. This is sum of squares total. Remember, if we take sum of squares between treatments and add sum of squares within treatments, we should find sum of squares total. 50 plus 32 equals 82. The only cell we have left is this one right here for sum of squares between subjects. And remember the way that this works. We take sum of squares within treatments, we subtract this value, and that leaves us with sum of squares error. So 32 minus something must equal 8. If we take 32 and subtract 8, we get 24. So that must be this value in here, 24. I think that's it. It looks like we solved the puzzle. In the next video, we're going to go through another example of a repeated measures analysis of variance. I'll see you in that next video. In the meantime, be safe.